This video will teach you stoichiometry part 1. In stoichiometry, there's mole to mole, mole to mass, and mass to mole, and mass to mass. Stoichiometry part 1 can be found in your book from page 361 to page 366. Now, what is stoichiometry? Stoichiometry is the process of determining the amounts of substances in a chemical reaction. I repeat, stoichiometry is the process of determining the amounts of substances in a chemical reaction. Therefore, it's important that we deal with amounts such as mole, mass, volume, and the like. Now, one of the requirements in stoichiometry is a balanced chemical equation. What is a chemical equation? A chemical equation is a representation of a chemical reaction. Again, we have to have a balanced chemical equation. Now, let's review how to balance a chemical equation. This is an equation of ammonia decomposing to nitrogen and hydrogen. So as we have discussed before, you have to account the number of atoms of each element in the reactant side and the amount of atoms in the product side. In this case, in the reactant side, we have 1 nitrogen atom and 3 hydrogen atoms. In the product side, we have 2 nitrogen atoms and 2 hydrogen atoms. So let's balance. So first, we balance nitrogen. Here, in the product side, we have 2 nitrogen atoms. Therefore, we have to make sure that we also have 2 atoms in the reactant side. So what do? We multiply this by 2. Therefore, you also multiply ammonia with 2. However, other atoms are also affected. In this case, hydrogen was affected. So let's now have the number of hydrogen. Now we have 2 times 3, so we have 6 hydrogen atoms. That is 2 times 3, so we have 6 hydrogen atoms. So here, in the product side, how many hydrogen atoms do we have? We only have 2. But I think you already know how to balance that. You have 6 hydrogen atoms in the reactant side. Therefore, to make this 6, we will multiply this by 3. Therefore, in the equation, you have to multiply 3 beside hydrogen. Again, in a chemical reaction or in a chemical equation, you balance the chemical equation by putting coefficient before the chemical formula. You do not put coefficients in between chemical formulas. So, let's check if we have a balanced chemical equation. We have 2 nitrogen atoms in both sides of the reaction. Hydrogen, we have 6 hydrogen atoms. We have 6 hydrogen atoms in the product. Therefore, we have a balanced chemical equation. Now, let's go back to stoichiometry. Stoichiometry, one of the requirements is for you to have a balanced equation. Again, for this case, we will only have mole to mole and mole to mass. We will have mass to mole and mass to mass next meeting. Let's have mole to mole. How can we relate stoichiometry in a chemical reaction? This means that 2 moles of ammonia will decompose to form 1 mole of nitrogen and 3 moles of hydrogen. I repeat, in this equation will tell us that we have 2 moles of NH3 or ammonia, which will decompose to 1 mole of nitrogen and 3 moles of hydrogen. With this, we can make a mole ratio. What is a mole ratio? Mole ratio means that for every 2 moles of ammonia decomposing, 1 mole of nitrogen is produced and 3 moles of hydrogen is produced. So therefore, 2 moles of ammonia is equivalent to 1 mole of nitrogen. Now, this can be interchanged. 1 mole of nitrogen is also 2 moles of NH3. Okay? So, this is our mole ratio. Alright, so we know how to make the mole ratio between ammonia and nitrogen. How about you? Can you make the mole ratio between ammonia and hydrogen? That's correct. 2 moles of ammonia is to 3 moles of hydrogen. Again, 2 moles of ammonia is to 3 moles of hydrogen. What is another mole ratio for ammonia and hydrogen? That's correct. That's 3 moles of hydrogen and 2 moles of ammonia. Now, let's say we have a problem. Let's say we have 3.12 moles of ammonia. How many moles of nitrogen will be produced? Again, for our problem, we have 3.12 moles of ammonia. How many moles of nitrogen will be produced? Alright, this is important. You always start with the given. You always start with the given. So our given is 3.12 moles of ammonia. This is our given. Then we have mole ratio. So, this is very familiar to you. You call this dimensional analysis. So, we cancel unit. Now, let's choose which will cancel ammonia but will produce nitrogen. That's correct. This one. So, we will use this mole ratio to get the moles of nitrogen in this problem. In this case, what are you going to use? Is it 2 moles of ammonia to 1 mole of nitrogen? Or 1 mole of nitrogen to 2 moles of ammonia? That's correct. We will use the second one. So, meaning for every 1 mole of nitrogen, there are 2 moles of ammonia. Using dimensional analysis, you can cancel moles of ammonia. So, you perform the necessary computation. So, that would be 3.12 times 1 divided by 2. So, what is the answer? And that is 1.56. Now, you have to consider in your final answer the correct significant figures and the unit. In this case, in our given, we have 3 significant figures. Therefore, in your final answer, you also have to express your final answer in 3 significant figures. And the unit is mole nitrogen. So, mole nitrogen.